Hello, we're going to start on trigonometry and the exam papers. Some of the questions that involve trigonometry might have constructions in them. So you can see this is 2019. I'm going to start on part B because you can see part A is a construction. And again, I'm not going to be doing the construction in this one. So I'm just going to move on to part B, 2019. So the diagram O is the center. You're given this diagram and you're basically asked to find alpha and beta, or A and B. So the first thing I would do in something like this is before I even attempt a question, I look at the diagram and on the page I would try and fill in as many points as I possibly can of information. Any angles I can fill in, any lines that might be radii, I'll fill in. So that's what I'm going to do here. And first thing I'm going to look at is the radius. So if you look at O, well, we've got a line running from O, and that's from the center of the circle out to alpha. So this is a radius. So this particular line here, I'm going to put two lines in that. And then O to W is also a radius because it's going from the center out to the edge, and also O to X. So all these lines are all exactly the same distance, all radius. The other thing then that you should notice is this particular part here, running from here to here, and then back across. This triangle is in a semicircle. And because it's in a semicircle, that means the angle at the top up here at alpha is going to be equal to 90 degrees. So again, this whole angle here is going to be 90 degrees. So now we can start filling in a few bits. Well, the first things first is this triangle here is an isosceles triangle because we've got this side and this side are equal to each other in length. So because of that, the base angles are equal. That means that 52 and alpha are the same number. So we're going to label in here that this is 52 degrees for alpha. So alpha equals 52 degrees. Because we know the whole angle is 90 degrees, that means we can fill in the next bit. So 52 then from 90 degrees gives us 38 degrees. And then just fill in the rest of them. If we have this triangle here, the pink triangle we call it because you can't see my cursor on the screen, so when I'm pointing at something here on the screen, you can't see it, so I'll just call it the pink triangle. We've got 52 and 52, which gives us 104, and 104 then from 180 is going to give us this angle here. So 104 from 180 gives us 76 degrees. So in there, 76. And again, if we've 76 there, we can figure out this one here because this is just a straight angle. So this is also 104 degrees. So now what we've got is we have in the blue triangle, we have 104 degrees in the corner, we have 38 degrees, and then we have 2b. So 104 plus 38 gives us 142, which means this angle here, 2b, is going to be 142 from 180, which is 38 degrees. So over here, we can write down that 2 beta, or 2b, is equal to 38 degrees. And again, look at the question. The question is asking us to find the value of b, not 2b. So b, or beta, is equal to 38 divided by 2. So beta then is equal to 19 degrees. So again, there's not much calculations to be done here in the box, but there's a huge amount to be done on paper and filling in all the angles. And I would always do that before you attempt some of these other questions. Let's move on to the next one. So 2019 question 9. So this is a big question and can cause a little bit of confusion. Let's have a look at it. So looking at this, there's an awful lot going on in this diagram. So what I would do here is I would label each of the parts and see what we can come up with. So we've got R as a radar station. So this in here, this is radar. Let's see what I'm going to be back in a second, get a different color. Okay, let's try that again. So here we've got a radar station, and that's here at R. Down here we've got P, which is the port, and this is where the ship is going to leave from. And then the ship sets sail. This here is S. And what is the circle? The circle is the radar, how far the radar goes out. So the radar operates in a circle. So S then is where the ship enters the radar. And T is where the ship leaves the radar. The only other part then is Q. Q then is the point where it's closest to the radar. And they're the main parts of it. What it does down below for part A is it takes this triangle, that triangle there, all the way down to P, and it just brings it in here. That's all that's happening there. So I'm just going to undo that. Just get it out of the way. So let's go down and have a look at it. So we're dealing basically with a small triangle after all of that, and you're asked to find QR. So you're asked to find this side here. So we put an X on it, and it's 30 degrees here, and then we got 120. Now normally what I would do here is I would probably redraw the triangle. So just drawing something fairly quick. We've got 30 degrees here. We've got 120 along this side. We have X along this side, and we're told that that's a right angle. It tells us there that PQR is equal to 90 degrees. So basically, we've got an unknown side, and from our revision notes, you should know what to do. So labeling each of the sides, working off the angle of 30 degrees, this is the opposite side, and working off the right angle, this is your hypotenuse. And the only thing that works with hypotenuse and opposite is sine. So we go with the sine of 30 degrees is going to be equal to the opposite over the hypotenuse. So the opposite of hypotenuse here is x over 120. So to figure out x, it's going to be 120 multiplied by the sine of 30 degrees. And that's equal to x. And when you work that out, x then is equal to 60 kilometers. And you can also, if you want to write in, you can write in that this is QR is equal to 60 kilometers. And we put lines on the outside of that because it's distance. So that's the first one done. Let's move on to the next one. The triangle QRS is taken from figure 1 and is shown in figure 3. So now what we're dealing with is we're dealing with the other triangle. So we are now dealing with that triangle there. And again, that one has just been brought down there. That's all. Let's go ahead and have a look at it. So again, QRS here. Let's try out this triangle, see if we can make sense of it. So we've got a right angle triangle here, and we have an extension. So this here is P, we've got S, we've got Q, and we've got R. We're told that this side is 100, and we've got a right angle. The question is saying use your answer from part A to find the length of QS. So we want to find QS, so label that side there as X, and it's using your answer from part A. Well, our answer from part A we found is that QR is equal to 60. So put in QR is equal to 60. And again, we're set up with a theorem. Well, maybe not a theorem of Pythagoras. We do. We have two sides that we know, and we have one side that we don't. So theorem of Pythagoras is always h squared, your hypotenuse squared, is equal to the other two sides squared and added together. So our hypotenuse here is opposite the right angle, so that's 100 squared. So 100 squared then is equal to a squared, which is x squared, plus b squared, which is 60 squared. Here are the two sides. So 100 squared minus 60 squared, and bring that across, equals x squared. When you do out the numbers there, you're going to end up with x squared is equal to 6400. So x then is equal to the square root of 6400, and then x, which is QS equal to x, which is equal to 80. So then we can go fill that in if needs be. Let's move on to the next one. So now the question is asking us to find PS. Give your answer correct to the nearest. So let's have a look at what we've got here. So we're looking for PS. So now what we've got to do is find this bit here. Okay. Okay, so if we want to find PS, we're going to have to go back to the original diagram. Let's go back up here. And again, I'm going to get rid of some of this stuff so we can actually see this a little bit more clearly. So if we want to find PS, we're basically going to have to deal with this triangle here. So you're talking about that triangle. We've been dealing with smaller triangles up until then. So let's go have a look at it. If I take that triangle and draw it below, so we've got a hypotenuse of 120, and we've got a triangle PRQ. So a triangle PRQ. So we're working off a triangle of PRQ. We're told this is 120 kilometers. This is a right angle. We know from our previous example that this is 60. So if we want to work out what PQ is, then again, Pythagoras' theorem kicks in. So we want to find out what x is. So again, h squared equals a squared plus b squared. And that's going to give you 120 squared. That's equal to x squared plus 60 squared. And then we're going to have 120 squared minus 60 squared. That equals x squared. Work these out separate. Don't do 120 minus 60. It gives you 60. That's not a good idea. So you're going to end up with x squared then is equal to 10,800 when you do it on the calculator. And again, you're going to get the square root of that. That's going to give you 103.923. Now, that only gives you x. So x now is 103.923. And that's running from here to here. It's the full length of PQ. However, when we go back to look up here, we already had QS. So QS, we figured out in part B, QS works out at 80 kilometers. So it's 80 kilometers from S to Q. And now we have the value from P to Q, which means we can actually figure out what's left. So S to Q is 80. So S is actually in here. So now what we have is S to Q is 80 from here to here, but we know the full thing is 103. So to find PS then, it's going to be 103.923, and you're going to take away 80. And that's going to give you finally what you're looking for. So that gives us 23.92. And it says give your answer to the nearest kilometer. So therefore you can say PS, or the length of PS then, is equal to 24 kilometers. Okay, we'll move on to part D now in part 2.